Hi, I'm Kev. This is the first 5-minute Friday, and today we're going to measure a tool length offset.
So tool length offset, or TLO, is just the distance from the spindle nose to the tip of the tool. Now that's really important because if the machine doesn't know the TLO, then you're going to have a crash. What's probably going to happen, say if I've got a 2mm cutter in here, plenty of space between here and the workpiece, it can come down. I put a tool call in, I put something longer in, like a centre drill. You can't even see any gap between the workpiece and the tip of the tool there. In fact, it's probably about there in relationship to the workpiece. So if this is going to move across the table, it's just going to hit, and it's either going to knock an encoder out or it's going to snap a tool, which is what we don't want. So we need a reliable and repeatable way of measuring this distance here. So we can do that over at the layup table.
So I'm sure there's a whole host of different ways to do this, but the thing that we do here is, if we need to know the TLO, so the distance from where the spindle nose is to the tool tip, we get a pair of matching angle plates that we know the height of, and we set it up between the two plates. And that way we can use a vernier height gauge to take a measurement of the blocks and then take a measurement of the tip. So by taking those two values away, you're going to get the distance from the spindle nose to the end of the tip. So in this case, I've pre-measured that, and we now need to enter it into the control, and we need to put it into HSM Works. So this is our CNC control, which is a Heidenhain TNC320, but the principle is going to be the same on whatever control you use. So in this particular view, we've got the runtime graphics and the code, so we're going to need to knock it into manual mode. And here's a typical CNC screen. We've got tool and spindle settings, current positions, and an overview of what's happening, and coordinate systems and things like that, runtime. So what will be common to most CNC systems is that you'll have a tool table. Now, on the Heidenhain TNC system, it's accessible on the first menu page, and it calls up a table in which you keep your tools. That's why they call it a tool table. And in the Heidenhain land, these files finish as a .t file. And I've got all the tools that we use on a regular basis here. And setting one up's pretty simple. We need to knock it out of edit mode. And from there, we can insert lines. We'll call this tool 11. I'm just going to repeat the center drill that we created before. Now we're in edit mode. We can give the tool a name, for which I need to actually plug in the keyboard to the control. So this particular model doesn't have a built-in keyboard, so we've got a standalone programming station. So we'll call this center drill. Center drill. It's got a length of 146.8, and that's measured from the tool table. And then we just need to go across and tell it what kind of tool it is. In this case, it's not a mill, but it is a center drill. Just page across there, center drill. And one weird quirk with the Heidenhain system is that there's a feature called lock, which has caught me out a few times. And these are all various settings such as wear compensation, break detection, tip angle, last use for monitoring tool length. But somewhere in here is a lock, which basically prevents it from being used until I guess it's been checked by a line manager or something like that. Tool lock TL, I think that's what it is there. Although you'll get an L symbol there, which will prevent it from being used. So that's something to look out for in your particular system. So we'll end that there, that's saved. and we can call that and use that in our program.